Okay, here's warm-up number 31. I'm going to start off by doing some division here. So I'm looking at this first polynomial and I'm noticing there's a missing x term. So that is going to be important. I'm going to imagine there being 0x in between the negative 3x squared and the 8. So I'm going to do synthetic division, although you could also do long division. So in synthetic division, that's what goes in that little box, right? You take this and set it equal to 0 and x would equal negative 2. Then I'm pulling out the coefficients here, and don't forget the 0 as a placeholder for the x term, okay? I'll leave a space and then make a bar like so. I'll pull down the 1, and then anytime I get a number down on the bottom, I'm going to multiply it by negative 2. So 1 times negative 2 is negative 2. Then I add these two numbers together to get negative 5. Take the negative 5, multiply it by negative 2, that's positive 10. Add, then multiply again, and add one more time. And my remainder is going to be negative 12. So when I build this polynomial, that is actually going to be the numerator of the remainder. The denominator is going to be what you're dividing by here. That's x plus 2. Okay, so this will be a 10, this will be a negative 5x, and this will be an x squared. So you kind of add 1 degree of x as you go to the left. Okay, and make sure you add in, always add in what your remainder is. Some people just write this without the plus sign there, but you need it there. And there's my x squared, and there is my solution. Okay. All right. So next up, it asks if these binomials are factors. So you could try to factor this, but I'm not sure if it'll factor evenly. But what we can do is just use synthetic division or long division. But I'm going to use synthetic division, and I'm just going to see if these go in evenly into the original polynomial. So let's see. I'd set up a negative 5 here. And then I've got 2, 1, negative 10. There's no missing terms in that in the trinomial. Okay, I don't have much space here, but I have just enough. Okay, I'm going to set up this one in just the same way. I haven't finished part A yet, but I'm just setting both of these up. So on both of these, I want to know if I get a 0 remainder. If I get a 0 remainder, it goes in evenly, and I do have a factor. If I get anything other than 0 in the remainder box, then it's not a factor. So I'm pulling down the 2, multiplying by negative 5, adding, multiplying, and adding. And I got positive 35 there, so I didn't get a 0, and that means that x plus 5 is not a factor. Okay, so let's try again here, pulling down the 2, doubling that, adding, and then multiplying, adding, and I did get a 0 in the remainder box. It went in evenly. That means x minus 2 is a factor. Okay. All right. Next up, I've got this longer polynomial. I'm going to list the possible rational roots, and the way I'm going to do that, it's going to be the factors of this over the factors of this. So the factors of my constant over the factors of my leading coefficient. So yeah, factors of negative 2 over the factors of positive 2. Which actually they're going to be the same factors in the numerator and denominators. So I'm thinking of integers that go into negative 2. Well, 1 does, but so does negative 1. So positive or negative 1 goes in, and positive or negative 2 goes into that as well. Same thing on bottom. Positive and negative 1 goes into 2. Positive and negative 2 goes into positive 2 as well. Okay? So there is my list of possible irrational roots. You could write them out one by one. It'd be, positive or negative 1 or 2 if you had the 1 on bottom, and then you could also get 1/2 or negative 1/2 if you wanted to write them out as a list like that. Okay, so now let's factor this completely. So what I'm going to do, I could try out these different possible rational roots and look for one where I'm going to get a 0 remainder. Okay, there's not that many of them, so it wouldn't take you too long, but just as a nice little shortcut, if I can get this to show, I'm going to graph this this polynomial. So I hit the y equals button. Let's see, 2x to the 4th minus 9x to the 3rd plus 7x squared plus 2x minus 2. Okay, I've got that all typed in. Now I'll hit the graph button, and I've got a kind of weird zoom going on here. I'm going to be looking for x-intercepts that are close to these possible rational roots. Okay, I've got a weird zoom going, so I'm going to hit zoom and then zoom standard to kind of get a 10 by 10, and then hopefully I should get some options here. Okay, so that one way off to the right, well, there's a root, but it's not going to correspond to any of these numbers. So I'm really just looking for 1 or 2 positive or negative, or 1/2 positive or negative. Okay, and I think I do have some options in there. I'm going to zoom in just to get a better look. And so there, I can see it better here. It looks like it crosses at -1/2. It looks like maybe +1/2 and maybe +1. So I'm thinking that those are my guesses. Okay, so I'm going to go -1/2, +1/2, and 1. So I'm just going to write this out. Here's my guesses. Oops, -1/2, +1/2, and 1. Those are the ones I'm going to try. I could tell the rest of them that there were definitely no x-intercepts at these other options. Okay, so let's try see if -1/2 is a factor. Okay, so I'm going to use my coefficients here, and I want to see if I get a 0 remainder or not. So I'll pull down the 2, multiply, add, multiply, so -10 times -1/2 would be +5, add, multiply, add, multiply, and hey, look at that, I did get a 0 remainder, so that means this one did work. Okay, now I could go back and try these others with the original polynomial, but what I'm going to do instead is use this polynomial, because it would have to go into this since I've already factored out x plus 1/2, right? So I'm going to try this in this one, and then it'll be further broken down to help me factor it completely as well. So it's a 2 for 1. If this does go in, it might not, I'm not sure. So let's pull down the 2, multiply, add, multiply. So that's -4.5. So I'm just going to switch to decimals. 12 minus 4.5 is 7.5, and I'll take half of that, and that's 3.75. And then that's going to give me -1/4, -0.25. So that one did not work. Okay, so that's okay. That one didn't work. I've still got one more option, so I'm going to try +1, and I'm going to go back to this one because I know that was just had this piece factored out. So, and I'll see if +1 is going to work. Hey, that one was a winner. Okay, so now what I can do is I can think, okay, I factored out, I'm going to start working down here, but from this original polynomial, I factored out x plus 1/2, right? That's when -1/2 is one of my roots. And then I factored out x minus 1, and what I have left over is this, right? Okay, so I've got it factored, but it's not completely factored yet because I can still factor that trinomial at the end. Okay, so let's go ahead and do that. Well, I can see I can factor out a 2 definitely. Okay, and then I could still try to factor this this trinomial here with a diamond problem. Maybe I'll do that up here to save myself some space. Okay, multiplying to get 2, I'd have to use 1 and 2, positive or negative, but then I can't get a -4 out of those same two numbers. So that one, this is completely factored now. Okay, and I'm going to have to use this to find my roots. Okay, so some of the roots are really easy. If x plus 1/2 equals 0, I'm going to use zero product property, then x would equal -1/2. Okay, so that's a root. And then this one, x equals 1. Okay, 2 can't equal 0. Oops, I'm off screen a little bit, sorry. 2 can't equal 0, but I still want to use this piece because I can set all of that equal to 0. So let's see what's going to happen when I do that. Okay, since the original polynomial is 4th degree, I should get 4 roots. I've got 2 so far, but there's going to be 2 more that come from this trinomial. Okay, now this isn't factorable. I already tried to factor it and it didn't factor. So I'm going to have to either complete the square or quadratic formula. And since I've got a relatively small even number as my b term, I think it's easier to complete the square. That's what I'm going to do. I'm going to look for the mystery number, which is not 2. So I'm going to, that's my spot for the mystery number. I want to move the 2 over the other side of the equation. Okay. All right. And let me use this little space down here. Now my mystery number is going to be b over 2 squared. In this case, b is -4. So that's going to come out to +4. +4 is my mystery number. Okay? Now I'm going to factor the left side. It should factor into something times itself. And this does here, it factors into x minus 2 times x minus 2. And you could set up a diamond problem if you wanted. On the right side, that's just 2. Now I take the square root of both sides. And don't forget, when you take the square root of both sides of an equation, there's a positive and a negative root. And then I'm just going to isolate the x by adding 2 to both sides. And I'm going to slip that 2 in front of the plus minus. And there's 2 more roots, right? Plus 2 plus or minus root 2. So I got 4 of them all together. Okay, that's it for this warm-up, and I'll see you next time.